Hello and welcome back to another video. In this one we'll be taking the topic of Laplace inverse, or to be more precise, the direct form of Laplace inverse. In the Laplace inverse we take the equations from the S domain and turn them into the equivalent of in the T domain, as opposed when we took the Laplace transformations where we took the equations in the time domain and turned them into the S domain. For example, if you were given the Laplace inverse, that's how the Laplace inverse is denoted by the Laplace inverse of 1 divided by s squared plus 1. Now this form looks very familiar to a Laplace transformation form, and if you have any knowledge in the Laplace transformations, you would find that sine of t would equal 1 divided by s squared plus 1, because sine, the Laplace of sine at would equal 1 or equal a divided by s squared plus a squared. Since we have this part is 1, then we find that a, or the gain, is also 1, so it's sine t. Now the Laplace inverse of 1 divided by s squared plus 1 equals sine t. So we took the equation in the s domain and turned it into the equivalent in the time domain. Let's take another example. For example, if we have the Laplace inverse of s divided by s squared plus s. Now, when you look at this, you'd say this doesn't look like a familiar Laplace transformation form, and you would be correct. All you have to do is take the common multiple from the denominator and the numerator. So you simplify the fraction. If you take s as the common multiple from both the top and bottom, you would find that it would equal to this form. And by cancelling the s, you are left with the Laplace inverse of 1 divided by s plus 1. And this looks like a familiar form of Laplace transform. So if you go back to the rules, you would find the exponential at is equaling to 1 divided by s minus a. And we have the Laplace inverse of 1 divided by s plus 1. So the Laplace inverse of 1 divided by s plus 1 is equal to exponential negative t. Let's take another example. Let's get rid of this. For example, if we have the Laplace inverse of s plus 2 divided by s plus 2 squared plus 1. Now this really doesn't look like a familiar form of Laplace, but as you can see, we have s plus 2 and we have s plus 2 at the top and bottom. Now if you take the shifting property out, we have a shifting property s plus 2 and s plus 2. This means there is an exponential, and it's plus 2, so it's negative 2t. The exponential of negative 2t is multiplied by, since we have a s in the numerator and we have a squared in the denominator, we can find that is it's the cosine of t, because we have s divided by s squared plus a squared. So we have cosine t, which is cosine of t. Now if you take the Laplace of this form, you would find it would be s plus 2 divided by s plus 2 to the power of 2 minus, plus 1. So you take the shifting property out, then you are left with 1 divided by s, so if you take the shifting property, you are left with s divided by s squared plus 1, and that would equal to exponential, the cosine of t, and you are left just with the shifting property, which is the multiple of exponential negative 2t, and that's the final answer of the Laplace inverse of s plus 2 divided by s plus 2 to the power of 2 plus 1. That's all for this video. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful. Thank you.